Hello everyone. So congratulations to each and everyone who is watching this video. It's because that our last video, the fourth video of this series, has crossed more than 1.2K views, and that is quite good response. I was not expecting this thing. So thank you so much everyone that you are liking our content. And if you're really liking it, then please click the like button, subscribe it, share to the people who really want to learn machine learning, generative AI, generative deep learning. Okay. And one thing I will say that machines are learning now. So that that we are training the machines. So it's the peak time to learn. Okay, because once the video complete, you should learn the things generative deep learning, so that you will be not replaced by machines. So I will say just watch the video till end. And I will also say that give a comment. Okay, just comment down that do you like the video, dislike it, anything you want to know, any question is there, yeah, or just summarize what you learned. Okay, so that will actually binds you to the content, that what you have learned, and that will be retained for your longer time. So let's start this video. So we are going to build our first CNN model. So what is CNN model actually? What is CNN model? So if you have any idea, then it means that the CNN is convolutional neural networks. Okay, so convolutional neural, what is the use of it? So in the previous videos, we have learned about neural networks, that it is multiple layer of neurons. Okay, that is called neural network. And convolutional neural networks actually applies on the images. Okay, so it is quite good for training images and getting inferences and getting instances from the images actually, that what are the like there are many use cases now, like image segmentation is there, image classification is there. So we in all those cases we use CNN model. Okay, so let's go on the book. So actually, if you are new to this video, I will say that just watch the previous videos. The link is in the description. So watch that, because with the continuity, you can go with us. So actually, this is the book. This is the book by the David Foster. I am really thanking David Foster for writing this amazing book. You can also go through it. You can just search on the Google, and you can download it. Okay. Now let's learn about building the CNN. So we'll be doing some hands-on learning, that how to do it. So first thing I will do is I will just open Google Colab. You can also open the Google Colab. I hope you are familiar with Google Colab, what it is. So from the Google Colab, we will actually, what we will do, we will code. Okay, so we'll see that how to make the CNN model. Okay, so this is going to be your first CNN model. I hope you really like it, and you'll be able to make this thing. Okay, so actually this is going to be somewhat quick video. Why quick? Because we are not like, deep learning is a part, but we are more focused towards making it generative deep learning. Okay, so we will cover it in a very simpler way, in a very efficient way. But in another series, we'll just go by code. We'll be we'll be just copy paste it, because we have to go fast, so that we can complete the other important things that are related to the generative AI. Okay, so first what we'll do, we'll just copy and paste it. Um, Actually, what for now I am just copying and pasting. But for you, I will say, if you are doing a lecture, then please write the code from your own. Okay, type it, because you will get somewhat habitual with that. That is quite important, so that your understanding will increase by writing the code. we'll just run from tensorflows.keras import layers and models. Okay, so there will be layers and models. Then we will be defining our input layer. What is our input layer? So just define it, input layer. We have defined it, input layer. Then what we'll do, we'll just go through this. This is going to be the code for layers. There are a lot of different layers we are making here. Okay, you can just have a look. You just have to see that what is happening. We will be just see here, convolutional layer is here, batch normalization layer is here, leaky URL is there. To some extent, I will explain it to you that what these things are. But you have to also be active. Okay, you have to also search on Google that what is the leaky relu. Okay, and what is the batch normalization. Because you have to be active in the learning process. You don't have to watch the lecture series, and you'll be, I hope that you have know about the tutorial hell. So actually, it is like in which you only write the codes when you are watching a tutorial, but unable to write from your own code. So that is tutorial hell, because you have to do hands-on learning with it. So I'm just copying and pasting the codes, um, because of the time constraint. Okay, because the video will go longer. Then okay, so these are the three layers we have made. Okay, so the one layer is convolutional layer. Okay, yeah, these have the different layers, and sizes are different. Just see here, filter is 32, but here filter is 64. Okay, so we'll see these things. Then at the end we'll be flatten the layer. So we are just writing the code of flattening, and then there is a dense layer. Okay, so we'll just put it out here. Okay, so actually, I am thinking to have a another video, a proper video on the deep learning series, because I can explain each and every point with that, so that you'll be able to understand that what is going on actually, what is the dense. So dense, okay, let me tell you, dense is just a dense network uh, of the neurons. Okay, neural networks. So here model is equal to model and input to output layer. Okay. So okay, wait. So here is we have made a CNN model. Okay. Now we will use four stacked. Just see this thing. We have used our four stacked convolutional layers. So here is four stack. Okay. Just see first stack, second stack, third stack, fourth stack. So let's write it. Okay. Uh, Block one, very good. So block two. So how I am getting these suggestions? It's because I have the Codium. Codium is quite a good code assistant. You can also download it. You can just download it, okay, and install it as an extension. So I'll make another video, or okay, fine. So we have the four blocks. You can see four convolutional layer blocks followed by batch normalization and leaky ReLU layer. Okay. So we'll see what is the batch normalization, what is the leaky ReLU. Okay. After flattening the resulting tensor, we pass the data through a dense layer. So just see here, we have flattened the layer. We have flattened the layer. Like if it is in the 2D, just see this, that this is the 2D matrix. Okay. I hope you are getting it, because it has some behind calculations. Somewhat mathematics is there, that it has a matrix, 2D matrix. What is 2D matrix? Just see, wait, I am showing you 2D matrix. Not in C. I'm just showing you 2D matrix. What is 2D matrix? It is just simple matrix. Just see. This is the 2D matrix. So 2D array, what you can call it, but matrix is here. Okay. So 2D matrix is here. Um, so what to do in a 1D matrix? You have to just flatten it so that it will be in the 1D matrix. Just see what is the 1D matrix. 1D matrix means just see, this is a 2D and this is a 1D. So so it converts the 2D matrix into 1D matrix, okay, so that it can be digestible to the neurons. And here you can say that after flattening, we have a dense layer of size 128, and after flattening the resultant tensor we pass through the dense layer and followed by batch normalization and the leaky ReLU. This is immediately followed by a dropout layer of regularization. Okay, so too much terms are there. We'll be defining it now. Okay, don't worry. And there will be 10 uh, size of the dense layer is 10, and then we'll have a model. So actually we have made a deep learning model. Okay, here we have defined input layer, then there is a block 1, block 2, block 3, block 4. So this is whole a layer. So let's do it in a one, because so that you'll get an idea that what is happening here. Just put it. Till then you can also google that what is the batch normalization. I'm just copying pasting it. Doing the things by yourself will make you a better coder. Okay, so if you don't have this book, then you can just download or you can purchase it. It's your choice. Okay, so we'll be running it in a one cell. Okay, fine. So I hope you are seeing this thing because it is getting too small. So here is block 1, block 2, block 3, block 4, and it whole is a model. Okay, here is the model. You can see here is the model we have defined model. So so let's see the model summary, that what is the model summary. Here is the model summary. So we will just put it, and you can see whole list of model summaries there: convolutional 2D, batch normalization, leaky ReLU. So here the shape is also there, parameters are also there, and at last you can see that trainable parameters are this much and this much. Okay, so this was the whole CNN layer. Okay, but what to do with this CNN? Okay, what to do with CNN? You have made CNN, then what will do? So if you are watching previous videos, then you have idea that in the previous videos we have done a model training, and in which we have we have worked on the MNIST dataset, and our accuracy was too low. Okay, our accuracy was very low. So we'll be seeing this thing. Okay, so let's actually you will be getting this code on the GitHub. So deep learning, generative deep learning. Okay, just see this thing. Our first model is there. It is actually made on the MNIST dataset. What is the MNIST dataset? You can see. Okay, wait. Just see. This is the MNIST dataset in which we had worked. But what was the accuracy? Just see this thing. The accuracy was only 50%, approx to 0.49. Multiply by 100 is equal to almost 49.7. Okay. So you got the accuracy of 51%. Okay. And on the testing data set, you got 50%. So to enhance it, what to do? Okay. So what to do to enhance it? To so we are going to implement our CNN model. Okay, CNN model is basically works on the image data set, that is okay. So this is cipher data set. Okay, I am so sorry that this is cipher 10 data set, not MNIST. This is cipher 10. What is the cipher 10? Basically, cipher 10 data set has 10 classes that you can see here. You can just search, okay, that there are 10 classes: airphone, airplane, automobile bot, and there are various classes there, and a lot of images. Okay, so let's do some coding. So we'll be just put this model and we'll be inferencing it. So I have already done it actually. So I'm just opening that file, and we'll be implementing and seeing that how much accuracy is there. Okay, so just see this thing. We'll be run. Okay, we'll be run one by one. So just see. I hope you are seeing this thing. So we are importing the libraries. Then we'll be. This is the model. So we'll be just running it. So let's search that what is batch normalization. So actually, you should also search everything. Just Google it. That what is the thing. Okay, just the batch normalization is the batch norm technique used to stabilize the training of deep neural network. Fine. So it is a normalization technique done between the layers of a neural network instead of raw data. So it is actually done in the mini batches instead of the full data set. Okay. So batch normalization um, is faster training, improved learning rates, reduce the need for dropout, reduce generalization error. So you can just have idea on this. You can go and read about what is the normalization. Normalization is a pre-processing technique for standardized data. Acha. So we will be taking a whole lecture on this thing for defining these terms. For now, you can just search it. You can have some idea from the Google. I'll be also taking the videos. What is the leaky ReLU? ReLU activation function is there. Okay, so what it does actually, it returning zero for negative inputs. So in the previous videos we have learned about it, that that really what a ReLU does, that it actually for the negative inputs it do it zero. Okay, so if it is negative, then it will just do it zero. So that is what ReLU is. We will see what is the leaky ReLU and these all stuffs. But first, let's see um, that how to implement this model. So here we have a model summary, and after that we'll be so now just see, import numpy, then there is data set, and we are downloading the data set cipher 10 data set. So from where we are downloading? We are downloading from data set, and data set is actually on the TensorFlow or the Keras library. Okay, so on the TensorFlow data set, there is a cipher 10 data set already saved. From there we are downloading our data, and then we have just defined it, the classes are there, and then we are just we are sort of normalizing it. Okay, so we have normalized it, and then we are optimizer, there is we are putting optimizer Adam, and there we are setting the learning rate, and after that we are also defining categorical cross entropy. So what is categorical cross entropy? So you just search on Google. Okay, I will say that search on the Google, try to find things on your own. Okay, um, because learning happens when you try to learn things. So actually you can just see that categorical means that there will be some categories, and in which we will be finding the losses. So in this documentation, it is not very much clear, but what is there? It is the mathematical formula in machine learning to help the computer learn. Okay, I got it. But just see this thing. So categorical loss is here. Sorry, categorical cross entropy loss is here. This is the big formula. You'll be seeing this thing. What the hell is this? But yeah, you can see that y true is there, y predict ln y predicting predicted is here, and there are classes, neurons, blah blah. So you can just have a look there. And after that we'll be fitting the model. There will be X train, Y train, and then batch size will be 32, epoch are 10. So we'll be just doing it. It will take some time, okay, in training, but maybe 1 or 2 minutes, so that okay, and then we'll go forward, not an issue. And it will actually train. It will actually train our CNN model. This CNN model, it will train again and again, 10 times it will go through, and just see that accuracy is 45%, and it is getting higher. Okay, just see this thing. It is getting almost 60%. Just see the, so it is almost 59%. And okay, links will be in the description. Not to worry, just go there, download it, use it. Okay, and there will be some evaluation that how it is working. So you can see here is 73%, but we'll do it once it will process. Then we will again run it and see that what is the accuracy. Actually, CNNs are now very good in image processing. CNN architecture. Let's see about CNN architecture. So, okay. So you can see that there is a convolutional layer, max pooling layer, then there is a dense layer. Okay. So you can have an idea. It is training now still. So now just see this thing. Open the image, new tab. Here is the image output. Then there is a convolutional layer in which it is given the input. Then there is a max pooling. What is max pooling? When we give the input, image is just what image is. Na? Image is just a matrix. Just see image matrix. So how a neural network actually process the image? So image is actually processed by the matrix. How it is done? Just see image matrix. Wait. Oh, okay. So matrix. Okay, I am getting very different image pixel matrix. Now you will be able to get that what is the image. So if you are seeing this image, this is the image of Abraham Lincoln, most probably. Yeah, you can see. So this is the image, this is black and white. So we have given, okay, open image. Okay, fine. So you can see that there are a lot of numbers. So in the darker there is a less number actually. Okay, like 0 may be the darkest one. Just see that 0 is the darkest one, and 0 to 255 it is divided. That 0 will be the black and 255 will be the white. So more whiter part is 251. You can see if you it is visible. So actually it is the matrix of the pixels. Pixels, what is the pixels? Pixels are the smallest unit of the image. Okay, so you got it. Now it is divided into pixels, and then these pixels are there. So this is you can say like matrix. And what we usually do is flatten this layer. Okay, so do it in a one matrix, one series of matrix. Like you can just put it this thing down it, and then after below it, okay, you can just put it and make a long string. Okay, so that's what the neural network process. Then okay, so our training has been done. Now we'll just evaluate our model that it is good or not. So our accuracy is 77%. Just see here. Okay, now it is 72% accuracy on the test data. So you can see, okay, that on the accuracy on the cipher dataset, training in the training set we have 77, but in the testing we are getting 72. It is evident because if you are learning something and exact question will come in the exam now, you'll be able to do more score, but there will be some new questions, then of course uh, you will have marks drop. Okay, so that is what is the drop here. So that's why it is 72, and CNN is actually better. So I will give the link of the GitHub link, so you can just access it from there. And if you're watching till now, it's very good that you are serious about it, because many of the people just leave the videos in between. That is not good. Okay, you have to be consistent if you want to really learn the things. Okay, so thank you so much for being with us. Meet you in the next video. Thank you so much.